Good day everyone. Today we are going to see how to prepare a detailed capacity sheet for a product manufacturing. This is very important topic whenever you are going to identify a specific bottleneck and also while having a capacity improvement program. First of all, we need to estimate the existing capacity, and based on the existing capacity we have to derive some action plans. And the format that we are going to prepare today is going to be a slight bit of lengthy, and it is going to cover all the aspects, like all the details of a product, including the equipments, the capacities, the minimum maximum volumes, the occupancies and all. And today let's see how to prepare it. The first column is stage, and the process that I am going to consider is going to have total 3 stages. Okay, so I'll mention this later. And the input size is going to be like there will be total 3 stages. The second column is going to be about the input size, and this is going to be in kgs. And the next column is about the output, and this is the yield factor. The next one is the activities or the operations, we can say, which are involved in this specific stage. The next one is the equipment capacities, so I'll mention as equipment. Here this is the capacity of the equipment, or let's mention the tag number of equipment, and this is the capacity. I'll mention in liters. So here the minimum volume, which is in liters, and the next one is the maximum volume. Here it is the minimum occupancy, and it is the maximum occupancy in terms of percentages. So first of all, let's try to fill these details here. The input size is, like for stage number 1, the input size is 110 kgs, and the expected output is going to be 88 kgs. So the yield factor is 88 divided by 110. And the activities or operations, let's make a note here. The first operation is hydrogenation reaction, and the second operation is workups. The third one is pH adjustment followed by distillation, and then it is unwanted salt filtration, and finally we got a distillation. And in this specific stage the product is a liquid product. So I'm going to match all these cells. And coming to the equipments, the first one is an autoclave. It's an SS autoclave, and the second one is an MSCL reactor. So these are only considerations, and again it's an MSCL reactor. And for this unwanted salt filtration I have mapped a SS match filter, and finally for distillation I have selected a SS reactor. Okay, so the tag number I am going to mention it later, and the capacity is 1000 liter of autoclave. And for workups again I have selected a 1000 liter capacity, and for pH adjustment again it's a 1000 liter capacity, and for unwanted salt filtration I have mapped a 150 liter SSH filter, and for distillation again I have mapped a 1500 liter reactor. So here comes the minimum volume and the maximum volume. So here I'll consider it as a 0.5 volumes to the input, so 0.5 multiplied with the input, and to this the maximum is going to be approx 5.7 times. Okay, and the next one I'll take around the same thing, like it's a workup, so it's going to be one volume. Like these are only considerations, and you can take based on the requirement. So for doing that you need to prepare a time and volume calculation sheet, and then you need to prepare this. And coming to this unwanted salt filtration, as we are going to retain only the salt inside the nudge filter, I am going to take the minimum and maximum as same. Why? Because we are going to have only the unwanted salt inside. So let's say this is going to be almost 1 time. Okay, and coming to distillation, so as this is going to be the product distillation, so we are going to have the minimum volume as the end point of distillation. So I'll consider this as 1 volume, nothing but the product, and the maximum volume is going to be the volume before distillation. So let's say this is approx 10 volumes. Okay, and now we have prepared the minimum and the maximum volumes, and now let's calculate the occupancies. So this is going to be 55 divided by this reactor capacity. And let's convert this into percentages. And again, coming to this maximum occupancy, this is going to be the maximum volume divided by the capacity. And here for this, we got a same. Why? Because the minimum volume as well as the maximum volume remains same for this filter. Okay, now let's this convert into percentages. So we got a maximum volume also, and now let's mention about the number of streams for this particular stage. So I don't want to confuse, so I'll be taking these streams as 1. Why? Because my production is going to be carried out in a single stream. And now again, coming to the considerations, so I'm going to consider the next column as the batch cycle time. So usually this will be referred as BCT in short. So here I'll be taking it as 23 for first reactor, 14 for the second reactor, and 30 hours for the third reactor, and 3 hours for the filtration operation, and it's 19 for the distillation operation. So if you are able to see here, these time cycles are going to be different. And if you want to identify the bottleneck is going to be the equipment which is going to consume more time cycle. So here in this case, the bottleneck is pH adjustment and distillation. This is the second MSCL reactor. It is consuming almost 30 hours of time. So it is the limiting. So we'll be referring this as a bottleneck in this stage 1. And the next column is production days per month. So this production days is going to be 26. The remaining 4 days are going to be the week offs. And number of batches per month, this is going to be the the next column, number of batches per month. So this is nothing but the production days per month, that is 26 multiplied by total hours in a day, so it is 24. So total number of hours divided by number of streams, here it is 1, and the batch cycle time, this is going to be 23 here. So here you got total 27 number of batches that you will be able to take in a specific month with respect to the first reactor, the autoclave. Okay, so I'll be rounding it off. And similarly, let's try to calculate for the remaining things. So I'll be taking the shortcut Control D. So if you are able to see the total number of batches, how it is varying from equipment to equipment. So here we got, this is as a bottleneck, like the pH adjustment and the distillation operation. So the second MSCL reactor is going to be the bottleneck. Why? Because it is going to take, we'll be able to take only 21 batches in a month. Okay, and now let's come to the second stage, In a similar way, we'll prepare the second stage and the third stage also. And the input that I am going to consider is approx 120 kgs, and for this 120 kgs, let's say the yield factor is approx 1.43 times. So input multiplied by the yield factor is going to give you the output. So it is almost 172 kgs. And here the operations that I'm going to consider are, the first is going to have a reaction. So it is a coupling followed by reduction. Okay. And then again I got some workups in the process to eliminate the byproducts which are formed. And the next operation is product filtration and solvent leaching. Leaching in the sense it's a purification technique where you are going to wash out the impurities. So I think by now you should have got a doubt why I have taken this product filtration and solvent leaching in a single operation. Why? Because I am going to perform the solvent leaching inside the filtration equipment itself. Okay, so finally I got the product drying after completion of leaching. Okay, so let's merge all these things now. Let's come to the reactors. So here I have mapped an SS reactor again, and then for the workups I have mapped a MSCL reactor, and for this product filtration and solvent leaching I have mapped a SS ANFT, and for product drying I have mapped a SS RCVD, and the capacities are going to be, for this coupling reaction I have mapped a 2 kL reactor, and for this workups again I got a 1 kL reactor, and for this ANFT I got a 2 kL capacity, and for this RCVD I got a 1000 liter capacity. Okay, so coming to this, the minimum volume that I have mapped for this specific operation is, let's say it's almost 1.5 times to the input. And coming to the maximum volume, so here let's say it's almost 12 times, let's say. Okay, and then here for this workups I'll take 5 and 6. So these are the volumes that you need to get it from the time and volume calculations. So just for understanding and to make this post easier, I'm going to consider here. And coming to the ANFT, I'm going to take only single. Why? Because the initial and the final volumes are going to be the same. So here I'll take it almost 8 times. And again for this RCVD, the minimum volume and the maximum volumes are going to be same. So there, during this drying, we are going to knock out the volatile content. Even though you are going to knock out the volatile content, the bulk density is going to get reduced during the course of drying. And just because of this, the volume might increase and it might be equals to the wet volume. So I'll be taking it as same. Okay. So let's say it is 4 times to the input. Okay, now we have prepared the minimum and the maximum volumes. Now let's come to the occupancies. So this is again going to be easier. So minimum volume divided by the equipment capacity. Okay, so here in this case this remains same. And the maximum volume, and now let's convert this into percentages. Okay, and here again I have taken same, the number of streams are same. And now the batch cycle time, here I have taken the batch cycle time, like these are only considerations in this particular post, and based on the requirement you have to take it from the time and volume calculation sheets. So let's say this is 34 hours, and coming to the workups it is going to have around 6 hours, and coming to filtration, let's say it's a slow filtration followed by slow solvent leaching, so I'll take it as 9 hours. And the next one is drying. Let's say the drying is going to be very slow in nature, so I'll be taking it as 25 hours. Okay, and I'll extend this production days per month. Why? Because it remains same. Okay, and now let's come to the number of batches per month. So instead of doing the calculation each and every time, I'll just drag it below and put on, and I'll be using the shortcut. So if you are able to see in the second stage, the bottleneck is going to be the first equipment, where it is going to take 34 hours. So the number of batches that you will be able to charge is only 18. So it is a limiting. And if you are going to improve this particular operation, or if you are going to reduce some of the waste from this particular operation, you can increase the number of batches. Thereby you can debottleneck the process. Okay. So let's come to the next stage. That is the last stage. So it is stage number 3. The input is going to be 100 kgs. And let's say the yield factor is 1.08 approx, and input multiplied by yield factor is going to give you the output. Okay, the operations that I'm going to consider here are the HCl salt formation. Why? Because this is a FEA stage, so I'll be taking it as the HCl salt formation followed by a carbon treatment. Okay, let's wrap it to make it shorter. And the next one is the filtration collection and product isolation. Usually in pharma, the last stage will be having a particle free filtration or any type of a carbon treatment to improve the color. Okay, so here I am going to collect the filtrate which has underwent the carbon treatment, and the next one is product filtration, and just a minute, and the final one is product drying. Okay, let's try to match this now. Let's see about the equipments that we have mapped. As this is a HCl salt formation, I have mapped a MSGL reactor for it. And coming to the filtrate collection and isolation, so I have mapped a SS reactor. Why? Because whatever the HCl that I have charged, let's say it's in saturated state, and also the reaction mass is free from water. So I have mapped a SS reactor. And the next one is the SS centrifuge. I have mapped, and finally, sorry, and finally product drying. For this product drying, I'll be selecting an SS RCVD. Okay, and coming to this capacity, so here I'll be taking 2000, and again here I'll be taking 1000, and here let's say it's a 48-inch centrifuge, so the basket holding capacity is going to be almost 300 liter, so I'll be taking it as 300, and for this RCVD I'll take it as 1500 liter. Okay, so these are only considerations. And coming to this volumes now, I'll take it as one volume initially. Okay, it is going to be 100, and the maximum is going to be approx 10 volumes. Okay, and coming to the second reactor, so here I got almost let's say it is 1.5 as a minimum volume, and here it is approx 9 volumes. And coming to this cake holding capacity, the minimum and the maximum are going to be same, so here I'll be taking it as 2 times the input. It's almost 200 liter, whereas the lip holding, I mean the basket holding capacity is 300 liter. And again for this dryers, I'll be merging it, and let's say the volume is approx 1.8 times to the batch size. Okay, now let's calculate the minimum occupancy and the maximum occupancy. So this is going to be the minimum volume divided by the equipment capacity, and here again the same. So here we got almost 90% occupancy, but it's not an issue. 66%. This is very poor, 12%. So let's convert this, and even here also I'll be using single stream. Okay, and the and here coming to this, the volumes that I'll be taking it as 12 hours, 15 hours, 8 hours and 16 hours. So these are the batch cycle times, I mean the operational times here for specific unit operations. And this 26, like the number of batches per month will remain same. Okay, so the number of batches per month, so this also the same thing, like 24 multiplied with the number of production days divided by the number of streams multiplied with the batch cycle time. Okay, so the maximum, I mean the minimum number of batches that I'll be take in this API stage are 39. Why? Because here the drying is the bottleneck, it is going to take 16 hours, and the next bottleneck is the filtrate collection and isolation, which means the filtration is a slow, that we can say, and the next one is isolation. Maybe we want some stepwise isolation. Okay, and this is only half sheet that we have done till now, and let's try to complete this. Okay, and now this is the total input in kgs, and the next one is total output, again in kgs. Okay, so this is going to be same, like the input that we have taken is 110 kgs, and now we have to define it with respect to the bottleneck operation. So first of all, let's match this. Okay, so this is going to be, first of all we need to identify what is the bottleneck. To identify that, I'll be using the Excel formula, minimum of the number of batches per month. Okay, multiplied by the total input. So this is going to be almost 2288 kgs, and again the same thing is applied to here. So the minimum of number of batches multiplied with the output. So here you got almost this, and now the same thing is applicable for the remaining stages also. Okay, minimum of multiplied with the input. So here it is, the minimum of multiplied with the output. Okay, so let's do the same with this also. The minimum of multiplied with input, and the minimum of multiplied with the output. And now we have estimated the total input as well as the total output, right? So now let's define the production per month with respect to the unit operations. Okay, so for a second I'm going to hide this tag number and the capacities. Why? Because the job is done with this. Just to make, or just to show the total table, I'll be hiding this for a minute, and finally I'll be unhiding this. Okay, so just hided it, and now let's mention this is production per month in kgs. Okay, and this is going to be the number of batches that is taken per month. Okay, with respect to a specific unit operation, multiplied with the total output. Okay, Okay, or else we'll do one thing, we'll apply dollars to this. Okay, and let's try to drag it. It's done. So coming to here, the same thing. Okay, and to this output I'll be applying dollars, and simply I'll be doing it. And coming to here, this is going to be the same, the number of batches per month multiplied by the total output, and to this let's apply dollar. Okay, let's go with this. And after completion of this, now the key thing is we need to estimate the API consumption coefficient. Okay, so consumption coefficient means the amount of input that is required to manufacture 1 kg of API. Okay, so for this I'll be merging this. Why? Because for single stage there will be only one API CC, so I'll be merging these things. And the API stage is the final stage, that is third stage, so here it is going to be 1 always. Okay, why? Because 1 kg of API consumption coefficient means the amount of input that is required to manufacture 1 kg of API. Since this is API stage, it should be equal to 1. And for stage 2, it is going to be the API CC of final stage multiplied with the yield factor. Okay, of the last stage. And coming to the first stage, it is going to be the API CC of n plus 1 multiplied with the yield factor here. So you got the API CC. Now let's try to calculate the equivalent API per month. So I'll be mentioning this as equivalent API per month in kg. Okay, so this is going to be the production per month multiplied with the API CC of that particular stage. Let's try to apply dollar here and drag it. Okay, so whenever you want to calculate this, the shortcut is going to be Control D, and if it's a MacBook, so it's a Command D. Okay, so here the same thing multiplied with the API CC, that is the API consumption coefficient. Okay, this is going to be same. Why? Because it is 1. So now once it is done, let's try to calculate the each stage equivalent. Okay, here it is, each stage output equivalent to API kg per month. So this is going to be somewhat critical to understand. Why? Because how much of API that you are going to get from, what is the API equivalent quantity from a specific stage that we are going to identify here. So it is nothing but the minimum of the API equivalents in the subject stage. So I have just used the Excel formula or Excel shortcut, that is minimum of the total unit operations. Okay, so this is This is how you are going to calculate each stage output equivalent to API in kgs per month, and finally the tonnage that you are going to get, API in metric tons per annum, how much API that you are going to get, and from this you can identify the bottleneck again. So this is equals to the total quantity, I mean the minimum quantity multiplied by 12, that is number of months, divided by 1000. This is to convert the kgs into tons. Okay, it is not accepting. Let's round it out. So if you are able to see, the minimum value is 34 here out of 34, 41 and 51. That means you will be able to get only 34 tons per annum, and the bottleneck is going to be the stage 1. And if you want to improve, you have to work out on this, and in order to identify the bottleneck in the total process, let's see here. So double click on it, or else just try to identify the minimum value. So it is related to the pH adjustment and distillation. That means if you are going to work out on this pH adjustment and distillation operations, and if you are able to eliminate some type of waste in the sense the operations which are not going to have any value addition to the process, and if you are going to delete or if you are going to avoid such type of operations, so here the time cycle can be reduced and automatically the API equivalence can be increased. Let's see, I'll try to modify it as 23, and now let's see, it has turned to 44 tons per annum. And now if you are able to compare, the bottleneck is going to be stage number 2, and let's see, in stage number 2, which is attributing to the lower capacity, so here it is 3401 kg. So that is the first operation, that is the coupling and reduction. That means I have to work out on this operation on this particular reactor. So if I'm going to reduce this time cycle from 34 to 30, now let's see again, it has increased to 46. That is the API manufacturing capacity has increased to 46, and now the bottleneck is stage number 1. So this way you have to focus, and you need to work out on the operations so that you will be able to debottleneck the particular process. And now let's come and let's unhide these things. Okay, and I have forgot to give these tag numbers. Let's say this is the first reactor, so I'll mention as R1, R2, R3, and this is a PNF match filter, so I'll mention it as NF1, and this is this reactor, so it's R4, R5, R6, and this is ANFD1, so AD1, and this is CD1, and this is R7, R8, CF1, and CD2. So this is how you have to prepare a capacity sheet. Let's try to bold these things, and to contain it, let's reduce the size. Okay, so this is how you can create a capacity sheet, and it will be containing all those things. If you want to view at a single point of time, so you can get any type of thing from this. So this is nothing but a capacity sheet, or else you can call it as a summary sheet also. And in few of the videos, people were requesting me to share these sheets, so I'll be sharing these sheets from a G drive. Just try to download it, and I'll be putting it as like the access can be unrestricted, so anyone will be able to download this. So this is how the capacity sheet is going to look. And thanks to everyone for watching the video. And if you want to get more updates, so you can please subscribe to our videos, and if you like the content, please share the videos with your dear ones. And also, if you want any additional things, or if you want any type of trainings, so you can switch off to cbtech.co for trainings on process engineering, Lean Six Sigma, and process safety managements.